Our project is about a soil stabilization by using rubber crumbs. Investigation take place on Whaltech High-Tech Engineering College. Aim. Our aim is to achieve a soil stabilization using a rubber crumbs powder by adding a rubber crumbs in a soil and thoroughly mixed, and by adding 2 to 4% of cement for the binding purpose. Objectives. As I said, we are using a rubber crumbs materials as a waste material for withstand the soil against the shear, and which will gives a load bearing capacity, that means increase the load bearing capacities of the soil. These are the methodology we are carried out to complete the project. Literature review. We concluded that after reading this literature review, we can withstand the soil by using a rubber crumbs. Abstract of the literature review. Due to increase the economic growth of the country, this will help it for the country. In Asia and the Pacific, as well as many other developing regions, plastic and rubber consumption has increased much more than the world average due to the rapid urbanization and economic development. From this literature review, soil stabilization with waste material. Soil stabilization means alternation of soil properties to meet the specific engineering requirements. Disposals of these solid waste is essential as these are causing hazardous effect on the environment. We need to recycle it quickly. Conclusion of this literature reviews. We have an idea that the rubber crumbs will withstand against the shear failure and have much higher shear strength than the normal soil. This process can implement in the road construction, whereas in the subgrade in the road pavement. This will increase the economics of India by recycling the tires as rubber crumbs and used in a soil stabilization of road constructions. Introduction of a project. These materials, most of which are non-degradable, pose environmental threat by polluting the nearby localities. Due to the fastest growth of the population and development activities, it led to discharge of huge waste materials. The soil physical and chemical properties are provided in this page. Tests to be carried out for the soil stabilization. The standard Proctor compact test, permeability test using a constant edge method, liquid limit and plastic limit, field density using a core cutter, unconfined compression test, and California bearing ratio test. First, the standard Proctor compaction test to determine the optimum moisture content and soil density for the soil by conducting a standard Proctor compaction test. Refer this table for determine the water content. Refer the second table for determination of density. We obtain a result of Proctor compaction. Optimum moisture content is 13.1%. Maximum dry density will be 1.8 grams per centimeter cube. Liquid limit. To determine the liquid limit of the taken clay soil, refer this table for the liquid limit values. As we gained a result for the liquid limit 36.6%. Plastic limit. To determine the plastic limit of the taken clay soil, refer this table, and we obtain the result. Plastic limit is equal to 25%. Permeability using constant edge method. To determine the coefficient of permeability of water in the clay soil, refer this table to obtain a result. We gained a result. Average value is equal to 0.139 centimeter per second. Number 5. Field density using core cutter method. To determine the field density from the clay soil using a core cutter, refer this observation and calculation for obtain a result. We obtain a result. Dry density of the soil is equal to 1.419 grams per milliliter. Test procedure. The test procedure experimental study involves performing a series of laboratory UCC test and CBR test on unreinforced and randomly oriented rubber crumbs powder reinforced soil specimen. UCC test. The primary purpose of this test is to determine the unconfined compressive strength, which is then used to calculate the unconsolidated untrained shear strength of the clay soil under unconfined condition. Refer this table to determine the unconfined compressive strength. As a result, we got unconfined compressive strength QU equal to 72 kilopascal and coefficient C equal to 36 kilopascal. CBR test. As per IS, the CBR test was performed on a remolded soil by static compaction. 4 sample is taken for the test, and we got a result of penetration of a piston in a normal specimen. Penetration by adding a 5% rubber crumb specimen. Penetration by adding 10% rubber crumbs specimen. Penetration by adding 15% rubber crumb specimen. Report the CBR value to be nearest second decimal. Take the average of value of 4 specimen CBR value of the test. Precaution to be taken. Clean the whole of the base plate and that of the perforated disc thoroughly. We get a result of a CBR value for not adding a rubber crumbs 8.7, by adding 5% of CRP 10.32%, by adding 10% of CRP 11.95%, by adding 10% of CRP equal to 11.95%, by adding 15% of CRP 12.17%. Hence, adding 10 and 15% is efficient in soil subgrade. Conclusion. We believe that the study after the several experiments found following significance in using rubber crumbs as a stabilizing agent. The maximum improvement in CBR is obtained while using 10 and 15% rubber crumbs having aspects ratio 3. For this project, we have referred S.K. Kannan and C.E.G. Gesto Highway Engineering, G. Venkatappa over J.M. Miller Orman M.E. 1994 Interference shear strength properties of roughness HDP. HMS 1952 Soil Mechanics for Road Engineering, London. Madhavi Vedulu Pavan Nathan G. and Professor B. P. Chandrasekhar NRRDA, New Delhi. Critical review of innovative rural road construction techniques and this impact. Saranjit Rajesh, International Journal of Advanced Engineering Science and Technology, volume number 8, issue number 113 2029. Usage of industrial waste products in village roads. Thank you for watching this video. Our project is about a soil